Hello everyone, welcome to 10:30 today. Here are your notes that will finish off Module 5, Day 2. Go ahead and take notes on this. My notes consist of about 2.5 sheets of paper, so that's how long they are. I'll probably break it down into a couple of videos, so just when one ends, start the next one, okay? Okay, so here we go. If we are going to learn about logistic growth model and logs today, we need to review some. So hold on, logs and logistic growth. We need to review some information that you would have learned in Secondary 3 about logs. Okay, so definition of log or logarithm. So logarithms are necessary for solving problems with weird exponents. So logs are an example of an invented form of math that's used to explain strange situations. Here's the basic definition of logs. Log base A of B equals C can be rewritten as A to the C equals B. Now A is the base of this log. It's a subscript. A is the base of this term right here, with C being an exponent or superscript. So put that in a box somewhere. A couple of you had me for Secondary 3. This is what we call circle the wagons. For no other reason than just remember that if you want to rewrite this, you start with the base and you circle around. Okay? So we're going to circle around to rewrite a log. And that's how that part works. Okay, so logs are a way to rewrite exponents. Here's why we need logs. If I gave you this problem, 2 to the box power equals 8, what would go in the box? Well, you say, well, 2 times what? 2 times itself, how many times equals 8? It's going to be 2 to the third power equals 8. And that's all fine and dandy. But what if I gave you another example and I said 2 to the box equals 7? Well, there is no number. We're not ever going to find an exponent that goes in the box. We're not ever going to find a number that goes in the box that's going to come out to be a perfect 7. So again, this is an invented form of math to explain this situation. So we are going to rewrite this exponent as a log. So we're going to rewrite it as log base 2. Now remember, circle the wagons. 2 to the blank is blank. Okay, so 2 to the, I don't know, power, let's call it box, I guess, is 7. So 2 to the box is 7. What goes in the box? Well, now we're going to use what's called the change of base rule. And the change of base says that you can put a statement like this into your calculator. And the way that you do that is, The way that you do that is if you say log base A of B, you write that in your calculator as log base 10 of B over log base 10 of A. You don't have to put base 10 in your calculator. You just find the log button on your calculator. Put that in a box. So we could figure out what goes in this box by saying log of 7 divided by log of 2. Now, if we worked on this, go to your calculator. Let me find the calculator. If I type in, let's see, where's my, I have a log somewhere here. Oh, right here. So if I type in log of 7, close parentheses, divided by log of 2, then I get the answer 2.81. So I'm going to come back here and write that down. So this is equal to 2.81. What does that mean? We can check it go back up to the problem that started us on this. If we say 2 to the 2.81 power, we should get 7 or something really close to it. I'll let you check that on your own. Okay. All right, so a couple of other things. Let's go ahead and write a few more definitions. Your calculator knows what to do with a common log. A common log is base 10. So log base 10 of x. Your calculator also knows what to do with a natural log. A natural log is log base e of x, which we more importantly write as ln of x. Hopefully you remember learning that before now. Moving on to the next page. I think I'm going to pause this video and we'll start another one.